All right, so then why does the brain prefer glucose? So can your brain use fatty acids? Technically, yes. And it but uses up a quarter of your calorie intake. So it uses up way more energy or nutrients than is proportionate by weight. Short and medium chain fatty acids, they can cross the barrier between your blood and your brain, but things that when your mitochondria and your brain, they're more focused on making ATP and energy because again, your brain is it's like that person in your dorm or apartment that likes to run their air conditioner all the time and have their TV and stereo, and they're not very green and they just use up a lot of electricity. So the mitochondria can still prefer, so the things that your mitochondria in your brain, they're just cranking out ATP as much as fast as they can because they want to, your brain just needs a lot of energy. But they can still perform beta oxidation. It kind of inhibits the functions. So now instead of just trying to focus everything, then rather than your mitochondria trying to focus all their energy into making ATP, now they have to juggle that and beta oxidation. So what happens is that the fatty acid metabolism in the brain interferes with that energy production and also generates acid as well. So the funny thing is that fatty acid metabolism, because your mitochondria are thinking, okay, do I generate ATP or do I do beta oxidation? They have to they only have a limited amount of resources. So the thing is that fatty acid metabolism is slower than glucose metabolism in the brain. Then beta oxidation also takes more steps as well. It takes more steps to go from that fatty acid to actual ATP. And your brain can use these small like hydrophil, so the things that you can break apart fatty acids and actually make ketone bodies from acetyl-CoA from fatty acids. So your brain can use these ketone bodies, but so this is, I mean, I don't think keto, or I think keto is coming back again. And there's always like a few people who like, some people when they get into keto, they get really into keto, and there would always be like at least one or two students who get really into keto and they're like saying, oh yeah, but your brain can still use keto, and they get really mad about this and defensively, oh yeah, your brain can use ketos. But yeah, absolutely, your brain can use ketones, but if you give your brain the choice between ketone bodies and glucose, your brain's going to go to glucose first. The glucose is, once you introduce carbs back in, your brain will rapidly shift its metabolism toward glucose metabolism over ketone metabolism. So yeah, if you're in ketosis, yeah, that's all your brain has. It has to use those ketone bodies. But as soon as you get that sweets back in, your brain is going to flip the switch back to carbs. All right, so what are ketone bodies? They are produced by the liver, and get yet reason number 30 something that your liver is so important again. Yep, so this goes back to the money in that analogy. Yep, so again, glucose is the easiest form, carbs are the easiest form for your body to metabolize. So yep, you can get energy from fats, you can get energy from ketone bodies, but your body is like, the fastest way to get energy is via carbohydrates. Okay, so ketone bodies, yet another reason why your liver is so important. And these are made from fatty acids. So again, this is not organic chemistry class, but all of these are carbons. Yep, so this is what we have here. So these are all carbon-containing molecules. And the interesting thing is that because they're not they don't have as much carbon chains as a fatty acid, they're actually more water soluble. So even though they have these nonpolar carbon-carbon bonds, they're, due to their size and also having these oxygen molecules, these are water soluble. And another bonus is that they can cross the blood-brain barrier. So this is a benefit for your brain if you're in ketosis, is that it actually has a source of energy in carbon. So again, all of these are carbon and all containing molecules that your brains and cells can use. What can you do? Well, you can just either snip off one of these carbons here, or break it apart back into double carbons, add coenzyme A, and you have acetyl-CoA again. Now your red blood cells can't use ketone bodies again. Why? If you don't have beta oxidation, you can't do this.